epsilon value to take? Because you get two values, right? Quadratic equation. Which epsilon value should we use?
Less than 1.
Huh?
Less than 1.
Less than 1. और more than 1 आया तो क्या करेंगे?
सर कंपोजिशन चेक करेंगे उसको.
Right. ऐसा नहीं है. We'll check all the values now. I want to check all the values, right? बोला था किसी ने चेक किया क्या? Did you go back and check all the values for all the problems we have solved so far? नहीं किया किसी ने? Okay. So let's see. Okay, so can you see this? Can you see this? Hello?
Yes,
Are
sir.
you able to see this? Can you hear me?
Yes, sir.
दिख रहा है क्या जो दिखा रहा हूँ मैं PDF or rather
हाँ सर.
app? Okay, so in this case, if you look at this was the first problem we solved, and so epsilon values are 2, right? 1.855 and 0.1448. That time I said you should select epsilon less than 1, which is not really correct way of deciding. So if you select 0.1448, conversion is 14%. You select 1.85, you get conversion as 188.5%. Because you have to put it in this equation for Z, and if you get more than 100% conversion, that means that epsilon value is not correct. I think that is the easiest test. Instead of just checking the first, just check the conversion. What do you get? It should never be more than 100%. It cannot be. ठीक है, समझ में आ रहा है? Any questions?
हाँ सर.
You can check composition also, but that will take more time. This is easier and faster way of doing it because conversion cannot be more than 100%. Okay. Next problem जो हमने देखा था. This was the one. Yeah, this was the second problem which we did. In this epsilon was yeah. In this case, we had both values less than 1. One was 0.54, one was 0.45, right? But the feed given was such that you cannot have more than 50% conversion. ये हमने discuss किया था, right? So we had to select 0.45 and not 0.54. So there are different criterias. इसमें अगर ये करते तो 54% conversion मिलता था, right? If you had selected this value 0.54, so 54% conversion मिलता था, which is not possible. Maximum possible is 50%. That's why we selected this value of 0.45. ठीक है, एनी क्वेश्चंस? ओके, देन इसके बाद we had done this problem. In this case, epsilon was 2.6 and 0.1. We selected 0.1, but if we select 2.6, we get conversion as 262%, which is not possible. So why करने की जरूरत नहीं है, इससे मिल जाएगा अपने को conversion. देखो, it should not be more than 100%. ठीक है, then in this case epsilon was only one value, यहाँ भी एक ही वैल्यू था. In this case again epsilon was only one value, right? So no question, no problem. Here also one value, no problem. यहाँ पर again we had two values, 0.268 and 3.7. So 0.268 select किया था. If you had selected 3.7, then conversion would have been 372%, 373%, which is not possible, right? So we selected 0.268, and y से भी आ जाएगा आपका, but वो faster है. Just looking at conversion, you can decide which value of epsilon to take. In this case, yeah, again there were two values, epsilon 8.2 and 0.87. We selected 0.87. यहाँ पर y calculate किया था हमने, but we can do z also. यहाँ पर z ये इसकी आप 8.23, तो you get 200% conversion, which is not possible. So this is a faster criteria to identify the correct epsilon value. यहाँ पर एक ही वैल्यू था. Okay, so this is 5, 6. So let us solve this problem now today. Yeah.
सर अगर एप्सिलॉन 1 से बड़ा होगा तो कन्वर्जन 100 से कम आ सकता है?
आ सकता है. लास्ट वीक देखा था हमने प्रॉब्लम. लास्ट वीक हमने प्रॉब्लम किया था ना, वही लास्ट वीक कौन सा प्रॉब्लम किया था हमने जिसमें 1 से ज़्यादा था? कौन सा एग्जाम्पल था? Just like we had seen that basis change किया था हमने, right? We selected different bases, and basis की वजह से it became, epsilon became large. 9.22, problem number 9.22. Let's see किधर गया वो problem. 9.22. 9.22. 9.14. हाँ, ये 9.22 है ना, right? This was case we solved, right? In which I think Weber had selected basis as 1 mole. We had selected basis as 10 moles of feed, right? Right, Weber?
यस सर.
So आपका value epsilon का different आया था because speed was different. So you got value of 0.8 and 0.08. Correct, Weber?
यस
Right?
सर.
In this case, when we took 10 moles as a feed, दो value of epsilon मिला. One was 8.23 and one was 0.87. Right? With 8.23, you get 200% conversion, and with 0.87, you get 21% conversion. So epsilon can be more than 1 because it depends on what you call feed, because यहाँ पर जो है denominator में z के it is initial moles of the reactant. ये अगर हमने बढ़ा दिया तो epsilon की वैल्यू बढ़ जाएगी because z is constant, that is not going to change. Conversion is not going to change. Our basis is different, that is why epsilon value is different.
Yes, sir. Clear.
Clear? Okay. Okay, so let's solve this next problem. It's again going to have similar situation. Yeah. Yeah. Let's solve this problem. Here also you'll encounter the same situation, epsilon ka. And let's see. So a gas mixture containing 25% CO, 55% hydrogen and 20% inert gas is to be used for methanol synthesis. The gases issue from catalyst chamber in chemical equilibrium with respect to the reaction. CO plus 2H2 gives CH3OH at a pressure of 300 bar and temperature of 625 Kelvin. Assume that the reaction mixture forms an ideal solution and Kf and K phi है ये, this is K phi are 4.9 to 10 to the power of minus 5 and 0.35 respectively. What is the percent conversion of CO? Right? Exactly similar है. It will depend on basis, right? यहाँ पर percentage दिया, जहाँ भी percentage दिया you can select any basis, right? यहाँ पर 1 mole or 2 mole दिया, वहाँ पर basis is already provided. So in this case, you can select any basis, and depending on the basis, your value of epsilon will change. Right? So book ने 100 moles लिया है. Let us take 10 moles again. So different करेंगे. Right? Let's take 10 moles of initial feed and see what happens. What kind of epsilon value we get. तो लास्ट टाइम हमने नाइट्रोजन का क्वेश्चन किया था, उसमें हमने डिफरेंट दिया था मोल्स. ओके, लेट्स सी. सो अज्यूम basis 10 moles of feed. That means we have CO कितना हो जाएगा? How much will be CO?
2.5.
2.5. Hydrogen?
5.5.
And inerts?
2.
So with this basis, now calculate the conversion. First calculate epsilon, then we'll calculate conversion. Okay? करो. Similar है problem, कुछ different नहीं है. यहाँ पर K phi दिया है हमारे को, right? And for gases, you can take K is equal to KF, because KF का value दिया है, right? And equation is K phi into P raised to power of nu, right? So ये equation रहेगा, K दिया है यानी KF दिया है, K phi दिया है, so we can use this, and pressure भी दिया है. Okay, करो. Let's see who can do it fast. Exactly similar problem है, only thing is इसमें K phi दिया है. वैसे K phi हम 1 लेते हैं, यहाँ पर K phi का वैल्यू दिया है because pressure is high. K phi is given because pressure is 300 bar, high pressure पे K phi का वैल्यू दिया है. ठीक है, let's see who can do it. This should not take more than 5 minutes. And once you finish calculation, raise your hand. हुआ किसी का?
सर 63% है, 63.59.
ओके, एप्सिलॉन वैल्यूज
0.6359 and 6.875.
तो कौन सा सिलेक्ट किया आपने?
सर वो <1 वाला.
नहीं नहीं, दोनों के लिए कैलकुलेट किया कन्वर्जन?
नहीं सर, 1 मिनट.
You cannot use that less than 1 वाला criteria because I told you this is not correct. अगर दोनों वैल्यू लेस देन 1 आया तो क्या करेंगे?
सर फर्स्ट वैल्यू का कन्वर्जन 25.44% और सेकेंड वैल्यू का 275.
राइट, सो 275 नहीं हो सकता, दैट इज वाई टू सिलेक्ट दैट 20 whatever 25%। 61 बोला अभी आपने, 63%।
सर एक्चुअली मैंने इनिशियल वॉइस 1 लेके किया, मतलब वो याद नहीं आया 2.5.
बट 25% इज नॉट करेक्ट। करेक्ट आंसर इज 61% कन्वर्जन। चेक करो कुछ गड़बड़ है क्या।
सर वो 5.5 माइनस 2 एप्सिलॉन होगा ना.
5.5 माइनस या करेक्ट।
सर
या
सर वो कन्वर्जन का परसेंट 61% है,
हम्म।
तो फिर सर उसकी एप्सिलॉन वैल्यू ग्रेटर देन 1 रही है.
हाँ तो ग्रेटर देन 1 वही बता ना, इट्स नॉट अ क्वेश्चन ऑफ ग्रेटर देन 1 और लेस देन 1, यू टू सी कन्वर्जन कितना आ रहा है, दैट इज द टेस्ट। दोनों दोनों वैल्यू ऑफ एप्सिलॉन के लिए z निकालो, gives you conversion less than 100%, that is the correct value of epsilon. That's what I was explaining, no? आपने सुना नहीं क्या बराबर जो बता रहा था मैं? Or was not clear?
सर समझा.
Maybe I didn't explain it properly. So that's why I've taken this problem. जिसमें भी आपको same question situation आएगा. You get two values of epsilon and then we have to select the right value of epsilon. Okay? अभी ठीक है ये दीक्षिता? 2.5 minus epsilon ये आएगा. Is this correct? KY?
Yes, sir.
Right? So this is what you'll get. इसको solve करने का, right? Direct मिलता है क्या calculator को? What is the value of this constant?
12.6.
So you have to open it or you can directly do it in calculator. कैसे किया? सिद्धि? Simplify किया था इसको?
सर करके.
Simplify करके?
हाँ.
फाइव पॉइंट फाइव स्क्वायर कितना है? बराबर है कि सिद्धि एंड दीक्षिता?
सर वो पहली वाली इक्वेशन डायरेक्टली कैलसी में डाली थी।
पहली बार डाला दी, डायरेक्ट डाल दिया। ओके, ठीक है, अच्छी बात है। ओके, तो एप्सिलॉन का वैल्यू निकाल सकते हो। व्हाट आर द एप्सिलॉन वैल्यूज यू गेट?
1.5
1.5
525
एंड
3.3108।
राइट। सो दो वैल्यू है, दोनों अबव वन है। आप कैसे सेलेक्ट करेंगे? वो जो पहला रूल बताया था मैंने, लेस देन वन इज नॉट एप्लीकेबल, राइट? सो वी नीड टू कैलकुलेट जेड सी ओ, राइट? जेड सी ओ में क्या आ जाएगा? न्यू आई इंटू एप्सिलॉन अपॉन एन ऑफ सी ओ एट जीरो टाइम, बराबर। न्यू आई क्या है? व्हाट इज वैल्यू ऑफ न्यू आई फॉर सी ओ? -1, राइट? एप्सिलॉन 1.55 डिवाइड बाय एन जीरो कितना है सी ओ का? 2.5.
2.5
So this will give how much value?
61%.
0.61. So if you select the other value, this will be how much? Double, right? 1.22 आ जाएगा, बराबर? नहीं, डबल नहीं,
132.32.
कितना?
1.32.
1.32. So this is 132%. This is 61%. So this is not possible, and that is why we select this one. ठीक है, समझ में आया लोगों को? Any questions? How to select the appropriate value of epsilon? Epsilon can be anything depending on the basis. Basis change होगा तो epsilon value change होगा. So less than 1 epsilon value जो rule मैंने बताया था, that is not correct. It depends on the basis. ठीक है, any questions, doubts? Okay, if there are no questions, then we proceed to the next topic. So we have seen so far gas phase reactions. Now we'll see liquid phase reactions. Okay, so we have defined K as pi of AI raised to the power of nu I. That's the definition of K when we started. So now if you want to calculate for liquid phase reactions, then you need to find out AI activity based on composition or concentration in the liquid phase, right? अभी Y लिया था हमने. We had used all the equations for Y. Now we need to find out for liquid phase, right? So liquid phase के लिए क्या करेंगे? AI is defined as Fi bar by Fi0, which is fugacity in solution for component I, divided by fugacity in the standard state. Now standard state for liquid phase reaction is pure liquid at 1 bar and reaction temperature. Whatever is the reaction temperature, that is the temperature taken for standard state, and pressure is 1 bar. And you can say because pressure effect is negligible for liquid phase, we can say that we can take this Fi0 as that of pure liquid. Right? That's how we have defined the standard state. So we can take that, and that will simplify our equation. K is equal to Fi bar by Fi 0 raised to the power of nu I will be equal to Fi bar by Fi raised to the power of nu I. And we have defined Fi bar is nothing but gamma I into xi into Fi, where Fi is the fugacity of ion solution. Fi bar is fugacity of ion solution, and gamma I is the activity coefficient of ion solution. Right? So if you take Fi bar by Fi, that is equal to gamma xi हो जाएगा. Right? So we can put in this equation for k is equal to pi of gamma I raised to the power of mu I and xi into xi raised to the power of mu I. This is nothing but k gamma into kx. Any questions on equation 1? Now k gamma is defined as equilibrium constant in terms of activity coefficient. That's how we define ky, kx, k gamma. Now accurate values of activity coefficients are rarely available. We have seen equations, but they are not measured values. Derived values रहता है. Therefore we set k gamma equal to 1. And this is assuming k gamma 1 कब हो जाएगा? जब activity coefficient 1 हो जाएगा, right? So we are assuming that ideal solution is applicable. Simplify कर रहे हैं, because we want to solve the problem. We assume generally ये assumption valid रहता है unless the concentrations are in the middle range. High concentration में रहता है because when it is almost pure solvent, activity coefficient is 1. When it is very dilute solution, infinite dilution, when the concentration is very low also, then it is activity is equal to 1. We have defined these two terms, right? We'll see those two. So for ideal solution, AI is equal to gamma xi, and we know that for ideal solution, gamma equal to 1, therefore AI is equal to xi. So if you know the concentration, you can use that instead of activity. Any questions on equation 3? That's how we have defined activity and activity quotient, right? Okay, so components present in large proportions obey Lewis-Randall rule, right? Lewis-Randall rule हम derive किया था Fi bar is equal to gamma xi into Fi, and for ideal solution Fi bar is equal to xi into gamma because xi into Fi because gamma is equal to 1, and this gives us Fi bar is equal to Ai into Fi because Ai is equal to gamma xi. ठीक है? Any questions on equation 6? Nothing but revision पहले का किया हुआ था. For ideal solution, gamma equal to 1, and therefore we get from here also we get xi ai equal to xi. For any, that means ai is equal to xi for what you call large proportions, right? Component present means high concentration, when concentration is high. So we get k is equal to kx, which is nothing but xi raised to the power of nu I. So if you know the concentrations, you can use that directly. ठीक है? Question 8. ठीक है, there are no questions. Now low concentration में क्या हो जाएगा? Standard state of solute is that solute obeying Henry's law. Henry's law define किया था हमने low concentration of solute के लिए, right? And now we are defining it as low concentration of molality equal to 1. So if you plot Fi bar versus molality, we get this is actual behavior, actual curve of Fi bar versus molality. And if you draw a tangent is essentially Henry's law because at low concentration it follows Henry's law. Fi bar is equal to some constant into this molality, right? And if you look at this one, the intercept at m equal to 1 is essentially standard state. That's how we define standard state for low concentrations. So Fi bar is equal to Ki into Mi, which is where Ki is Henry's law constant and Mi is molality. सब definition पहले ही किया हमने, we are just revisiting it. Any questions on equation 9? In Henry's law constant, we have seen that Fi bar is equal to Pi bar Ki into equal to Ki into Xi. We compare these two equations, we get Fi bar is equal to Xi into Fi. 5 क्या था? Right. Fi bar is equal to Xi into Fi, and we have seen Fi bar is equal to Ki into Xi. Right. So we get Fi bar is equal to Xi into Fi, and we get Fi equal to Ki. That means for dilute solutions, we can take Fi as Henry's law constant. And if we compare 6 and 9, Fi bar is equal to Ai Fi, you get Fi bar is equal to Ki into Mi. 6 and 9 क्या था? Fi bar is equal to Ki Mi, and 6 was Fi bar is equal to Ai into Fi, right? So what you'll get is Fi bar is equal to Ki, and from where we get Ai is equal to Mi. So for dilute solutions, you can take activity as nothing but molality, and for higher concentrations, you can take activity equal to concentration. So once you know the concentration in terms of mole fraction for higher concentrations, and concentration in terms of molality for low concentrations, we know the activity, and then we can use these for calculation of K, which will tell us about conversion. बाकी प्रोसीजर सेम है जो हमने गैस फेज के लिए यूज़ किया था. Only in this case, we are approximating, assuming ideal solutions, and approximating Ai is equal to concentration for higher concentrations and Ai equal to molality for lower concentrations. Any questions, doubts? इतना याद रखना है आपको कि हायर कॉन्सेंट्रेशन है तो Ai इक्वल टू एक्स है, एंड लोअर कॉन्सेंट्रेशन दैट मीन्स सॉल्यूट है, डाइल्यूट सॉल्यूशंस है, तो Ai इक्वल टू Mi इज मोलालिटी. ठीक है, देयर आर नो क्वेश्चंस,
सर एक
लेट्स
डाउट,
सॉल्व. या
सर वो एक्चुअल बिहेवियर जो है वो कंसंट्रेशन एट एट इन्फिनिट डाइल्यूशन के लिए है या वो अलग कंसंट्रेशन के लिए है?
क्या बोले?
सर वो अभी ग्राफ है ना एफआई बार वर्सेस मोलालिटी का,
इज फॉर इनफिनिट डाइल्यूशन. हेनरीज लॉ ऑलवेज फॉर डाइल्यूट सॉल्यूशंस. ये आप
नो
पहले
सर
किया हमने. इज फॉर डाइल्यूट
वो
सॉल्यूशन.
एक्चुअल बिहेवियर का जो कर्व है वो भी इन्फिनिट डाइल्यूशन के लिए या फिर वो अदर कंसंट्रेशंस के लिए है?
This is always for infinite dilution or dilute solutions, because you're drawing a tangent at molality equal to 0. So it is applicable for low values of molality. जितना ज़्यादा molality होगा उतना ज़्यादा deviation होगा. This is the actual value and this is the Henry's law constant value. So there is a difference. जितना ज़्यादा रहेगा value molality का है ना, उतना ज़्यादा difference आएगा, variation आएगा. जितना close to 0 रहेगा match होगा Henry's law से. Does that answer your question?
यस.
So Henry's law is always applicable for very dilute solutions, because we saw that, right? We have seen कि we calculate the solubility of oxygen in water, right? Oxygen का solubility बहुत कम रहता है water में. It's not even 1 molar, 0.00 में कुछ होगा. So at that very low concentration solute in a solvent, you can apply Henry's law constant. Henry's law, right? जैसे concentration बढ़ता है, then we go for Lewis figacity rule, and there we have seen that you can use AI equal to XI, concentration, not molality. ठीक है, डिफरेंस समझ में आया? concentration very low and this lower region, that means we can take activity is equal to molality. Molality यहाँ पर 1 का लिमिट दिया है, but as close as possible to 0, that means 0.1 रहेगा तो और अच्छा रहेगा. 1 की तरफ जाएंगे तो वेरिएशन बढ़ते जाएगा, that means error will increase. And for higher concentrations we can use AI equal to actual concentration, that is mole fraction. ठीक है, any other questions? Okay, so let us solve a problem. This is a problem from Smith. It's actually a solved problem, but ये problem में बहुत गड़बड़ करते हैं examination में setter. They give you only this portion and they expect you to solve the problem. Right? Acetic acid is esterified in the liquid phase with ethanol at 373.15 Kelvin and atmospheric pressure to produce ethyl acetate and water according to the reaction this. If initially there is 1 mole each of acetic acid and ethanol, estimate the mole fraction of ethyl acetate in the reaction mixture at equilibrium. इतना डाल के छोड़ देते हैं. But ये solved problem है. Solved problem में he has taken data from tables which are given in the book. तो बहुत बार क्या होता है कि ये यही इतना देते हैं एग्जाम में, एंड मेनी टाइम्स इट हैज हैपेंड, 4-5 बार आ चुका है एग्जाम में ये. तो क्या होता है कि यू आर स्टम्प्ड कैसे करने का, देन यू हैव टू आस्क फॉर डेटा, राइट. एंड अगर करना है प्रॉब्लम सॉल्व तो डेटा लेके करने का, नहीं है तो देन यू शुड से इट इज इनसफिशिएंट डेटा. एंड जो बोलते हैं ना अज्यूम डेटा, अज्यूम करके कर सकते हैं आप, बट वो अज्यूम करने के लिए आपको डेटा याद रहना चाहिए कि क्या क्या है, राइट. सो डेटा फॉर delta HF 298 and delta HF 0 298 and delta HF delta 0 298 are given in for liquid acetic acid, ethanol and water in table C.4, right. ये table है स्मिथ का. For liquid ethyl acetate the corresponding values are, so ethyl acetate का values यहाँ पर दिया है. अगेन ये बुक एग्जाम में नहीं आता, एग्जाम में इतना देते वो लोग, जो भी सेट करता है वो देखता ही नहीं है क्या कर रहे हैं. सो बुक में सब दिया है वैल्यूज. So delta HF 0 298 for ethyl acetate is minus 480,000 joules and delta GF 0 298 for ethyl acetate is minus 332,200 joules. And table C-4 is this one. इसमें हमारे को बाकी सब निकालना पड़ेगा, which is acetic acid. Acetic acid is this one, right? और क्या चाहिए? Ethanol and water, right? Ethanol liquid phase में चाहिए हमारे को ethanol, right? Liquid phase and water. Right, again water in the liquid phase. So ये वैल्यूज लेकर प्रॉब्लम सॉल्व कर सकते हैं हम, राइट. सो अभी टाइम नहीं है, बट आई गिव यू दिस एज होमवर्क असाइनमेंट. स्मिथ का सॉल्व प्रॉब्लम ही है, बट ये वैल्यूज लेकर फर्स्ट फाइंड आउट हीट ऑफ रिएक्शन फ्रॉम हीट ऑफ फॉर्मेशन, देन डेल्टा जी ऑफ रिएक्शन फ्रॉम डेल्टा जी ऑफ फॉर्मेशन, राइट. डेल्टा जी मिला तो देन यू कैन गेट के, दिस विल गिव यू के एट 298, राइट. के एट 298 मिल जाएगा. उसके बाद हमारे को रिएक्शन टेम्परेचर इज 373, राइट. देन यू हैव टू यूज दिस and Vent off equation to calculate K at 373 Kelvin. And once you get K at 373, then you can calculate conversion. बाकी सब सिमिलर है जैसे हमने अभी किया था गैस फेज के लिए, राइट। ए का इन टर्म्स ऑफ कॉन्सेंट्रेशन नहीं, कॉन्सेंट्रेशन लेने का के इन टर्म्स ऑफ के एक्स. Once you know the value of k, you can find out the value of epsilon, and that will tell us what is the conversion. ठीक है, कर सकते हैं ये प्रॉब्लम.
यस सर.
कितने लोग करेंगे घर पे? I want to see hands. Good. I'll share this PDF on the Google Drive, and I will expect that you solve this problem. Simple है, ज़्यादा कुछ नहीं है. सब वैल्यूज दिया है मैंने, टेबल कॉपी किया है यहाँ पर, लेके करने का है. ठीक है. कल मेरा लेक्चर नहीं होगा, ट्यूसडे का लेक्चर मैं नहीं लेने वाला हूँ, ओनली मंडे का लेने वाला हूँ. देन रेगुलर लेक्चर जो अपना वेडनेसडे का होगा, वेडनेसडे को हम मिलेंगे. ठीक है. बाय वेडनेसडे आई एक्सपेक्ट दैट you will solve this problem and have an answer. ठीक है. Any questions? Okay, so we can stop here.